This is the Precalculus Spring 2017 ACP preview, and this is over conics, especially ellipses and hyperbolas. This first problem look at is kind of a conics problem. It's kind of conics conceptual problem. The intersection of plane and a double napped cone is shown in the diagram. What type of conic section is formed by this intersection? And we talk about these double napped cone question problems. Sometimes you'll see this with a drawing as you have here, sometimes without a drawing. And basically, if you see a drawing like this where the thing is cutting slightly at an angle, you should be able to look at this and recognize that this can only possibly be an ellipse. Now, if you're given a word problem, it says, what is the conic section, and I'll just abbreviate conic section CS, of a plane that is parallel to the base of a double napped cone. Put D in cone. Well, a parallel plane would be just like this, and I hope you could see that if we did something like this, it would intersect and cause a circle. Another type of question you can be asked, the same as this one, the parallel cone question, but you can say, what if it says instead perpendicular? Instead of parallel, right? What if it says perpendicular instead of parallel? Well, a perpendicular plane will look something like this when it intersects the cone, and will cut out, when you look at it sideways, a hyperbola. And so you just have to be mindful of what you could possibly be asked. So this is a very easy question. It will take less than half a minute at most. And number 6 here is a related question. If a plane intersects a double napped cone at a parallel to the slant height of the cone, what type of conic section is formed? Well, parallel to the slant height, not parallel to the base, but parallel to the slant height, that's another one, because if you go parallel to the slant height like this, what you end up with is a parabola. So it can be perpendicular, you'll have a hyperbola. Parallel to the base, you have a circle. In this drawing, you have an ellipse. But parallel to the slant height is how you get a parabola. So that would be our correct answer for 6. This 6. Next, the graph of an ellipse is shown. Which equation represents this ellipse? Basically, what you look at in a form of an ellipse, and I'm going to go to our ACP formula chart here. This would be our ACP formula chart. You see the standard form of an ellipse. And what you have is your A over here. A represents your semi-major axis. So that would be the square root of whatever this is. And B is going to be your semi-minor axis. So if we go back to our problem that we're working on, we say which equation represents this ellipse. Now, the graph should be good enough for you to recognize that you have a 10, this distance here, is 10 units. And that's our major axis. So our semi-major axis is equal to 5. And so we're looking at some place where we have 5 squared, or 25. So A and B are going to be disqualified based on that alone. And then you just have to look at the remaining two choices, C and D. You just have to look at the placement. You have X, you move 1 to the right, so that's going to be X minus 1 under the X, and down 2, that'll be Y plus 2. So this is it. And if you have any doubts about this, you can go to your T-CX calculator just to verify that, and we're going to graph this choice C and see if we get the same thing we get in the graph above here. And you can, prior to analysis, just do this yourself. So we go to, in our graph page here, we go to Menu, Graph Entry Edit, and we go to Equation Templates 3, and then we go to 4, Ellipse. And center form, we get this. So we get X minus 1, and that's going to be over, I think it was 9. Let's check to be sure here. Yeah, 9, so that's going to be 3 squared. So we go here and put in 3 squared, and then we have Y, and it's going to be minus negative 2, because that's how we get Y plus 2. So let's make sure I have this right. Minus negative 2. And then we have over here at the bottom 5 squared. And if we press enter, we should get the same thing. So we have the center point right here. And we can do other analysis features on this ellipse. But for now, we know this is a correct answer, C. Next problem. A hyperbola has foci at -1, -2, and 13, -2, and an eccentricity of 7/6. What is the equation of hyperbola in standard form? Well, this is really going to be one where you can really try out graphing your hyperbolas and seeing which one looks right. One thing you can do is, I'm going to put this right here. I'm going to have to go back and look at this. And you can try these one at a time, and then we're going to be able to evaluate the features of the T-CX calculator. So we go here, and I'm going to go to Control I, and we're going to add graph, and we're going to go to Menu, 3, Equation Template, and this time Hyperbola 5, and we have to look at east-west or north-south, so it's going to be X minus Y or Y minus X. So we can go here and look at it to remember. We're going to go X minus Y, so we go back here, and that's going to be this east-west thing. So just looking at this, again, we're going to try answer choice C. We're going to put X plus 6, that's going to be that's going to be minus negative 6, and then Y minus 2. X minus negative 6, Y minus 2. X minus negative 6, and right here y minus 2. And also we're going to go to put in the other features here. Well, we're going to have 6 squared here, and then we have 13. Well, 13 is not a perfect square of a number, so we're going to have to put in square root of 13 in the denominator here. And so we're going to put 6 squared here, and we're going to put in square root of 13 here. And we graph that, and we get this kind of looking hyperbola. And we can check, since this hyperbola is over here, we can check. It looks like our we were asked about our foci, is it? Or our vertices, let's see. Foci. So, -1, -2. Let's check that out. No, our foci are going to be over here at +1, +2, it looks, or about. So that's not going to be it. So we have to go look at another hyperbola, and let's try choice D. And we're just going to switch the signs here for the -6 and +2. So we go here again and tab up to that equation. So we're going to go x minus 6, again minus -6, and we're going to go to y minus -2, and we graph this, and this time we're going to get our foci, -2, comma -2, let's check that out. -1, comma -2, let's check that out. Yeah, that could be right. But let's check it. Now to check, we evaluate, we go to menu, and we go to analyze graph, and then analyze conics, choice 8, and foci is what we want, and we click on the graph, and we get a focus here at -1, comma -2. That checks. Next, the eccentricity of 7/6. Well, that's what we're looking for. So if we go to menu, we'll go to analyze graph, and then 8, analyze conics, and then we choose 8, eccentricity, and we click on this, and we get this number here, 1.16667. Okay, and that's going to be, we can look at that, that's going to be 7/6. So therefore, we've done a little analysis. We've concluded that D is our correct answer. Next, 7. Ellipse center at origin has a vertical major axis of 12 units and eccentricity of 0.5. What is the equation of the ellipse? Well, vertical major axis is going to occur under with the y term here. And if we have 12, this is going to be the form y squared over a squared. And so 12, if we have a squared equals 144, then a is equal to 12. And so that would be our, not our vertical major axis, that would be our semi-major axis. This one right here, we would have a semi-major axis of 6. Okay, so these would both be a equals 6. A equals 6. So that's how we get a vertical major axis if our semi-major of 12, our semi-major axis is 6. And so that'd be A and B are not possible. And next, between these two, we look for eccentricity of 0.5. So we're going to try this answer choice C. See if that works out. And to do that, we go to a we'll get another page here, Control I, add graph, and we're going to go to menu, 3, 3, and we're going to go to, in this case, an ellipse. I think that's it, isn't it? Yeah. That's the ellipse, and that's going to be it. We're going to have x minus 0 because we're centered at the origin, and we're going to have 9 or 3 squared here, and for the y we're going to have y minus 0, and for this one we're going to have 6 squared. And so we graph this ellipse, and so we have a major axis we can see of 12, right? From the bottom here, -6 to +6, that's 12. And we check for eccentricity by going to Analyze Graph, and then 8, Analyze Conics, and finally we check 8, Eccentricity, and we click on here, we get an eccentricity of 0.866. Well, let's check that out. .866. No, we need one of 0.5. So let's try this 27 one over here. So I'm going to change this up a little bit and go to Tab, and we're going to change this one right here to square root of 27. And then we graph, and we get this kind of ellipse, and we want eccentricity of 0.5. We're going to go to Menu, Analyze Graph, Analyze Conics, Eccentricity. We click on this, and we get an eccentricity of 0.5. And so with an analysis here, our correct answer is going to be D. And here's the last one we're going to look at. A hyperbola has vertices at 2, -5 and 2, 3. The slope of one asymptote is -1/2. What is the equation of the hyperbola? And what we have is the vertices are going to be surrounding the center. And so for this one here, we're going to have a hyperbola, and the vertices are at 2, -5, so down here, and up here at 2, 3. And so those are the vertices. So we're going to be looking at a hyperbola that looks something like this. And our eccentricity and our slope of our asymptote, our sine asymptote, is going to be, one of them is going to be -1/2. So this would be at m, or slope, equals -1/2 of that sine asymptote. So what we have here between -5 and 3, this is going to be a value of 8, a span between that. And what we're going to have for that is our semi-major axis is going to be square root of underneath the y, so it's going to be one of these two things here. And if we can tell between the two, our center it's going to have to be at x -2, so it could possibly be that one, or x -2, because that's how we get over to the right. we're going to have x minus 2. So that means we're going to cancel out these guys right here. And so now we're between, I think it's going to be D. And we're going to try to enter this and see if we get a slant asymptote, because that's going to get the y less than the extent of the x, which can create a narrower slope that's less. So we're going to try to enter this one right here and see if we get our slant asymptote of negative 1/2. And so we go here to our calculator, Control I, add graph, and we go to Menu, 3, and Equation Templates, and we're going to graph a hyperbola. And let's see if we have the east-west or the north-south. I think it's going to be a north-south one. Let's check to be sure here. X, Y. Okay, we're going to have x minus y. Let's check on that. So x minus y. So we're going to have x minus 2. And it's going to be y. What is that going to be? Y plus 1. So minus negative 1. So minus negative 1. And down here, what do we put down below? We're going to put, we'll get 4 squared and square root of 8. So 4, so it'll be 4 squared. And then over here, we're going to get square root of 8. So we graph that, and so we have the right kind of hyperbola, except we want this a y one. XY, let's check it out. Yeah, it's going to be this guy right up here. It's going to be B instead. So that's actually going to be, let's check this one out here. We're going to get a y minus 1. Yeah, let's check this one here. So menu, add graph, and we're going to go to menu, 3, 3, and 5 hyperbola, and we're going to go north-south here. So y minus, I don't know why I got that wrong. So y minus negative 1, x minus 2. So y minus negative 1, x minus 2, and we go down here, we're going to have y is going to be 4 squared for 16, and this one here is going to be 8 squared for 64. Let's make sure that's right. Yeah. Okay. And now we graph, and this is what we get. Do we get a slant asymptote here of 1/2? Let's check. Menu, analyze graph, analyze conics, and asymptotes. So we click on this, and we get one of the asymptotes of y equals negative 1/2 x. So we finally got around to it and figured out that B is our correct answer. So if we just fumble around and look at this, we're going to eventually get these right. Good luck with these problems, and as always, thanks for viewing.